So today's lesson is lesson 1.2, solving equations with applications and applications. So we're going to talk about the I can statement. Now remember, this comes off of your unit 1 peach colored sheet that you picked up yesterday and put in your journal. So solving equations and applications. Our I can statement for lesson 1.2 is I can write and solve multi-step equations and justify my steps. So we're going to start by solving equations using inverse operations. If the variable you're solving for shows up only once, you can identify the operations that have been done to that variable and reverse them in the opposite order. So the first thing that we're going to do is we're going to talk about what exactly is happening to x. So when I see x right here, I see that the first thing that happens to it is I subtract 3. So first, we subtract 3. The second thing that's happening to the x is the result after I subtract 3 is being divided by 2. And the last thing that I see that's happening is then we add 7. Okay, so we're going to reverse and do the opposite. So we're going to reverse the order and use the opposite operation. So I like to list them. So whatever you did last, you're going to do first. So add 7, but the opposite of adding 7 is subtracting 7. So we're going to minus 7. The second thing that we're going to do, let's see, is divide by 2. Well, the opposite or the inverse of divide is multiply by 2. And then the last thing that we are going to do, well, it says that the first thing we did, excuse me, was subtract 3. So the opposite of subtract 3 is add 3. All of this is happening to the x. So let's see, x equals, well, this whole thing equals 23. This whole thing equals 23. So we're going to start with that. We're going to take 23 and we're going to subtract 7. Let's see, 23 minus 7 is 16. Then we're going to take that 16 and we're going to multiply it by 2. 16 times 2 is 32. And then we're going to take that 32 and we're going to add 3. That means that x is actually 35. X equals 35. Because all of these operations done to x started off when we first started, all of those operations done to x equals 23. So that's what we start with. Now, I always like to check that. So we're going to check it. How do we do that? Well, we let x equal 35. And we plug that into our original equation. X minus 3 divided by 2. X minus 3, all divided by 2. Plus 7 equals 23. All right, so now I'm replacing the x with a 35. Whoops. I didn't mean that to turn into a straight line. I want it to be an arrow. There we go. So 35 minus 3 over 2 plus 7 equals 23. When you do a check, you're just operating on one side. Whatever side has the variable, that's the side that you're manipulating. So what is 35 minus 3? Well, 35 minus 3 is 32. So I have 32 divided by 2 plus 7 equals 23. Well, 33 divided by 2 is 16. So I have 16 plus 7 equals 23. But what is 16 plus 7? Well, 16 plus 7 is 23. And when you end up with a statement that is true, 23 equals 23, you've completed your check, and you know that you solved your equation correctly. X does in fact equal 35. Now, this way, this idea, this concept of taking a really challenging equation, like in example A, and finding out what's happening to X and do the reverse opposite operation is the same thing as using inverse operations. It just helps you think about what you need to do first. Okay? So let's do the same thing with example number B, or example letter B. So what's happening to X? Well, X is in a parenthesis, and I see the first thing that I'm doing to it is I'm adding 1, plus 1. The next thing that I do, well, I take that whole parenthesis and I multiply it by 4. And then after I multiply by 4, what am I doing with that quantity or that product? Well, I'm subtracting 2. So when we think about the reverse opposite, well, the opposite of subtract 2 is add 2. The opposite of multiply by 4 is divide by 4. And the opposite of add 1 is subtract 1. Well, what do all of these operations that we do to X equal? They equal negative 6. So if I take negative 6 and I add 2, I get negative 4. If I take negative 4 and I divide it by 4, I get negative 1. If I take negative 1 and I minus 1, I get negative 2. That means that X equals negative 2. I'm going to check that. I'm going to check that right here. So we start with our original equation, 4 times the quantity of X plus 1 minus 2. Oops, I put minus 6, I'm sorry. Minus 2 equals negative 6. Well, we're going to let X equal negative 2. So 4 times the quantity of negative 2 plus 1 minus 2 equals negative 6. Well, negative 2 plus 1 is negative 1. So I have 4 times negative 1 minus 2 equals negative 6. But what is 4 times negative 1? Well, that's negative 4. Negative 4 minus 2 equals negative 6. Same signs, add and keep. The signs are the same. You add them together and keep the sign. A negative 4 and a negative 2 give you a negative 6. Negative 6 does, in fact, equal negative 6. We've performed our check correctly, so we know that the answer is negative 2. But now, in this space right here, I'm going to solve the equation using inverse operations, which, again, is really what we're doing. But the reason we try to think about what's happening to X and reverse it is because when you see an equation like this, sometimes you're not sure where to begin, okay? So, according to this, we can add 2 to both sides. That's the first operation that we're doing. We're going to add 2 to both sides. That gives me 4 times X plus 1 equals, let's see, negative 6 plus 2 is negative 4. It says the next operation is to divide both sides by 4. Divide both sides by 4. Well, that gives me X plus 1 equals negative 1. The last step is to subtract 1. And we find out that X equals negative 2. So it doesn't matter whether you use this whole idea of reverse opposite or inverse operations, you're still going to get the same answer. You're still going to get the same answer, okay? So we're starting off with solving by the idea of what's happening to X, all right? Let's go to exercise number 2. So now we're going to use inverse operations. Now we're going to use inverse operations. So the first thing that I'm going to do is get rid of the parenthesis by distributing. Negative 2 times x is negative 2x. Negative 2 times a positive. Actually, I'm doing that on the wrong one. I need to reverse the operations first. So let's see. Sorry about that. So what's happening first? X is in a parenthesis. What are we doing to it? We're subtracting 4. What are we doing next? Well, the second thing that we're doing is multiplying by negative 2. And then what are we doing? Well, we're adding 8. So we're going to reverse opposite. Reverse opposite. So that means the opposite of plus 8 is minus 8. That's the first thing that we're going to do. And the opposite of multiply by negative 2 is divide by negative 2. And the opposite of minus 4 is plus 4. So I'm going to take whatever the solution for x was. What are we doing to the x? All of these things have to equal 2, and that's the number that I start with. So I take 2, and I'm going to subtract 8 from it. 2 minus 8 equals negative 6. All right, the next thing I'm going to do is take the negative 6 that I just got and divide that by negative 2. I'm dividing it by negative 2. A negative divided by a negative is a positive. 6 divided by 2 is 3. So I bring that 3 over here, and then I add 4. 3 plus 4 is 7. So that means that x is going to equal 7. That is our solution. So now we're going to use the distributive property. We're going to get rid of the parentheses. Same exact equation in example A as in example B. Same exact equation, but we're using a different method. Negative 2 times x is, well, that's negative 2x. A negative 2 times a negative 4, well, a negative times a negative is a positive, and 2 times 4 is 8, plus 8 equals 2. Okay. First thing I'm going to do is combine like terms. So that gives me negative 2x. 8 and 8 is 16 equals 2. I'm trying to get x all by itself. I'm trying to get the x variable all by itself. The first thing I have to do is subtract 16 from both sides. Subtract 16. So I have negative 2x equals negative 14. Now I have negative 2 times x. The undo of multiply is divide. So I'm going to divide both sides by negative 2. We always divide by the number attached to the variable, right? So x equals 7. Look at that. That's the exact same thing as what we got in example A. So what method do you want to use? It doesn't matter what method you use. You need to use the method that works best for your brain. Both ways are going to give you the same result. And even if your directions say use the reverse operations or use the distributive property first, what I want you to do is to use the method that works best for your brain. Okay? So in example number 3, or exercise number 3, we're going to solve the equation by, we're just going to solve it using, we're going to solve it the old way, using the distributive property. So I'm going to rewrite the equation. 5 times the quantity of x minus 3 all over 8 plus 2 equals 12. So the first thing that I do is I always split my equal sign with what I call a river. I'm going to draw the river, right? So I'm trying to get x all by itself. The first thing I see that I have to move away is this plus 2. Well, the opposite of a plus 2 is a minus 2. That gives me 5 times the quantity of x minus 3 all over 8 equals 12 minus 2 is 10. The next thing that I can do is, hopefully you see that this is the fraction 5 over 8. And if I multiply both sides by the reciprocal, 8 over 5, multiply by the reciprocal, 8 over 5, these cancel out, and I'm left with x minus 3 equals, well, 10 times 8 is 80 over 5. Well, what is 80 over 5? Well, 80 divided by 5 is 16. So x minus 3 equals 16. Last step, add 3 to both sides, and I find out that x equals 19. I'm just going to do a quick check on this one. I'm going to do a quick check. So I have 5 times, what is the value of x? 19 minus 3 all over 8 plus 2 equals 12. So I'm not doing anything with the 12. I'm just simplifying the left-hand side. So let's see, what is 19 minus 3? Well, 19 minus 3 is 16. So I have 5 times 16 divided by 8 plus 2 equals 12. Well, what is 5 times 16? 5 times 16 is 80. 80 divided by 8 plus 2 equals 12. Well, what is 80 divided by 8? Well, 80 divided by 8 is 10. 10 plus 2 equals 12. 10 plus 2 is 12. 12 does in fact equal 12. Remember, when you get this true statement, this is a true statement, you realize that your solution is correct. So x does in fact equal 19. Okay, so now let's go to exercise number 4. So some of these answers are not going to be integers, meaning they're going to be non-integer rational numbers, meaning that we're going to have fractions, okay? So I'm going to draw my river. The first thing that I have to get rid of is this minus 7. The opposite of minus 7 is plus 7. So I'm going to add 7 to both sides. Add 7. Well, that leaves me with x divided by 3 equals negative 2 plus 7 is 5. X is being divided by 3. What is the undo or the inverse of divide by 3? Well, the undo or the inverse of divide by 3 is to multiply by 3. Why do I write it as 3 over 1? Well, I want you to see that these cancel out. So I'm left with x over 1, which is just x, equals 15. So my first answer, x equals 15, is actually an integer. What if I do this second equation? Well, notice that I can't move this 7 away from the x because they're both being divided by 3. So the first thing I have to do is get rid of the divide by 3. What is the opposite of divide by 3? Well, it's multiply by 3. So I'm going to multiply both sides by 3. I do that, so I get rid of the denominator. X plus 7 equals, well, 2 times 3 is 6. Last step, subtract 7 from both sides. X equals negative 1. X equals negative 1. Alrighty, let's look at example number 5. So we set up equations that translate the following verbal phrases into mathematics and then solve the equation. So 10 less than, that means we're going to subtract, and this is a turnaround word. So whatever we do, we're going to subtract 10. Well, what are we subtracting 10 from? 5 times a number. That's 5x. So let's write that first expression. I have 5x minus 10. Results in equals 35. Equals 35. Okay, so that's the equation. I'm going to rewrite it and we're going to solve it. So 5x minus 10 equals 35. Draw my river. The first thing I have to do is get rid of the minus 10. What's the opposite of minus 10? Well, it's plus 10. So that gives me 5x equals 35 plus 10 is 45. Next step, 5 times x, the undo of multiply is divide. Divide. X equals 9. Now, we're asked to check this, to check our answer for reasonableness. So that means that we have to take this equation and we have to let x equal 9 and see if we get a true statement. Let's see, 5 times x is 9 minus 10 equals 35. Well, 5 times 9 is 45, and 45 minus 10 equals 35, and 35 does in fact equal 35. So we've checked our equation, we've checked our solution. So we come up with this true statement, 35 equals 35. That means our solution, x equals 9, is in fact correct. All right, let's look at our second translation. 3 times the sum of. Well, the sum of, that's an addition problem, but it's going to get put in a parenthesis. We're going to take 3 times that. Well, what two things are we adding together? Well, we're adding together a number and 7. So that's what I put in here. Is, that means equals. So I have 3 times a number plus 7 is, 3 times a number and 7 is increased by 10. Is increased by, that means I add 10. Is increased by 10. And the result is 4. Okay. So there is our equation. Let's see if we can solve it. So the first thing that I'm going to do is get rid of the 10. The opposite of a plus 10 is a minus 10. That leaves me with 3 times the quantity of x plus 7 equals -6. This is 3 times the quantity. What's the undo of multiply? Divide. So I can actually divide both sides by 3 and get rid of that number outside of the parenthesis. That leaves me with x plus 7 equals -6 divided by 3 is in fact -2. I need to now get rid of or eliminate the plus 7. The opposite of a plus 7 is a minus 7. X equals -9. Now I want to check my answer. I want to do the check. So I'm going to take that original equation, 3 times the quantity of x plus 7, close my parenthesis, plus 10 is 4. And now I'm going to plug in -9 for x. So 3 times the quantity of -9 plus 7, close my parenthesis, plus 10 equals 4. Well, let's see. I have 3 times -9 plus 7 is -2. 3 times -2 plus 10 equals 4. Well, what is 3 times -2? A positive times a negative is a negative, and 3 times 2 is 6. -6 plus 10 equals +4. But what is -6 plus 10? Well, -6 plus 10 is in fact 4. I end up with this true statement, which means that my solution, x equals -9, is correct. Okay? All right. Let's go to example or exercise number 6. So we're going to look at the equation. 5 times the quantity x minus 3, close my parenthesis, plus 2x equals 4 times the quantity x plus 3. So it says by using the distributive property, write equivalent expressions for both sides. So we're just going to use the distributive property. Well, 5 times x is 5x. And 5 times -3 is -15 plus 2x. And I can actually simplify this. The 5x and the 2x give me 7x. So the left side of my expression is 7x minus 15. Now let's look at the right side of my expression. Well, for the right side of my expression, I also have to distribute. 4 times x is 4x. And 4 times 3 is 12. So 7x minus 15 is equivalent to 4x plus 12. Now it says to solve the equation for x. So we're going to take our two simplified expressions that have been set equal to each other, and we are going to solve. Notice that we have variables on both sides. We have variables on both sides. Well, when we have variables on both sides, we need to get all the variable terms onto one side and all of the constants on the other. I always try to put my variable terms on the left. So I'm going to subtract 4x from both sides. I want to eliminate that 4x or move it from the right side to the left side. And when you go to the opposite side of the river, you use an opposite operation. 7x minus 4x is 3x. 3x minus 15 equals 12. Now I need to get the constant, negative 15, to the other side. Well, the opposite of negative 15 is positive 15. So I'm going to add 15 to both sides. Remember with equations, whatever you do on one side, you must do to the other. So I have 3x equals 12 plus 15 is 27. We're going to divide both sides by 3, and x equals 9. Now again, it asks us to check. Check to make sure that the solution that you got is true, but you need to check it in the original equation. Why are we checking it for the original equation? Well, we checked the original equation just in case we made a mistake when we were distributing or something. So we're going to check using the original equation. 5 times the quantity of x minus 3 plus 2x equals 4 times the quantity of x plus 3. Now remember, since our solution is 9, that means that anywhere I see an x, I'm going to put the number 9. So let's rewrite that. 5 parenthesis x is 9, so 9 minus 3 plus 2 times x, which is 9. 2 times 9 equals 4 times the quantity. Remember, x is 9. 9 plus 3. All right, let's do some simplifying here. So 9 minus 3 is 6. So I have 5 times 6 plus 2 times 9 is 18 equals 4 times the quantity of 9 plus 3, which is 12. Well, let's take it a step further. What is 5 times 6? 5 times 6 is 30. So I have 30 plus 18 equals 4 times 12 is 48. Well, what is 30 plus 18? 30 plus 18 is 48. And 48 does, in fact, equal 48. So we've done the check with the original equation, which proves that our solution, x equals 9, is, in fact, true. Example number 7. Same thing. We're going to solve and do the check. I'm going to distribute right here. 7 times x is 7x. 7 times negative 2 is negative 14. Negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9 equals 5 times x is 5x. 5 times negative 3 is negative 15 plus x. So remember, we want to combine like terms. On the left side of the equation, I can combine the 7x and the negative 3x and get 4x. And I can combine the negative 14 and the negative 9 and get negative 23. That equals, on the right side of my equation, I can combine the 5x with the 1x and get a 6x minus 15. Now remember, I try to always move my variable terms to the left, my constants to the right. So I'm going to subtract 6x from both sides. I know that's going to give me a negative x term, but I don't care. 4 minus 6 is negative 2. So I have negative 2x minus 23 equals negative 15. Now I'm going to add 23 to both sides. I got to move that constant to the other side. Opposite side, opposite operation. Opposite side, opposite operation. So that gives me negative 2x equals negative 15 and 28 is, or sorry, negative 15 and 23 is a positive 8. Last step, divide both sides by the number attached to x. I'm going to divide both sides by negative 2. And I find out that x equals negative 4. Now again, I have to do the check. And I'm going to do the check in the original equation. So my original equation, 7 times the quantity, x is negative 4. Negative 4 minus 2, close my parenthesis, minus 3 times x plus 3. That looks like negative 4 plus 3. Close my parentheses. Equals 5 times the quantity. X is negative 4. Negative 4 minus 3 plus x, which is negative 4. All right, so let's do some math. I have to take care of what's inside of the parentheses first. Don't forget that. So I have 7 times negative 4 and negative 2. When the signs are the same, you add and keep. 4 plus 2 is 6. Keep the sign. That's what I mean by add and keep. Minus 3 times the parenthesis. When the signs are different, you subtract and keep the sign of the bigger number. 4 minus 3 is 1. The bigger number is negative. Negative 1. Equals 5 times the quantity. Same signs. Add and keep. The signs are both negative. I'm going to add the two numbers together and keep the sign. Negative 7. Plus a negative 4 is the same thing as minus 4. So let's multiply. 7 times negative 6 is negative 42. A negative times a negative is a positive. 3 times 1 is 3. Equals 5 times negative 7. A positive times a negative is a negative. Negative 35 minus 4. So on the left side, the signs are different. So I subtract. 42 minus 3 is 39. Keep the sign of the bigger number. Equals, on the right side, the signs are the same. Same signs, add and keep. Same signs, add and keep. 35 and 4 is 39. Keep this sign. We have, in fact, done this correctly. So the solution, because we have a true statement that tells us that our solution, x equals negative 4, is in fact correct. Our last example, example number 8, says write an equation and solve. The perimeter of the pentagon is 61. Remember that the perimeter just means that you add up all the sides. Add up all sides. So if the perimeter is 61, 61 has to equal, let me fix that. That's a little messy. So 61 equals, well, let's see, I have 2x minus 1. So I'm going to write that 2 times the quantity of 2x minus 1. Plus, I have 2 sides with a measure of 4x plus 2. 2 times the quantity of 4x plus 2. Plus 3x minus 1. That's my last side. So I'm going to distribute. Let's see, 61 equals 2 times 2x is 4x. 2 times negative 1 is negative 2. Plus 2 times 4x is 8x. And 2 times 2 is 4. Plus, don't forget that 3x minus 1. Let's combine like terms. Let's combine all of our x's. I have a 4x plus 8x plus 3x. So 61 equals 4 plus 8 is 12. Plus 3 more is 15x. I have a negative 2 plus 4. Well, negative 2 plus 4 is positive 2. Minus 1 is positive 1. So that's my final equation. That's what I'm trying to solve. I have to get x all by itself. The first thing I'm going to do is move that positive 1 to the other side. Opposite side, opposite operation. 61 minus 1 is 60 equals 15x. Divide both sides by the number attached to the variable, which is 15. So 4 equals x. So x equals 4. The second part of this says, well, what are the dimensions of each side? Well, 3 times 4 is 12. Minus 1 is 11. So this side is 11 inches. What about this side? 4 times 4, well, that's 16. Plus 2 is 18. So this side is 18 inches, as is this side, 18 inches. Last one, 2 times 4. 2 times 4 is 8. Minus 1 is 7. So this side is 7 inches. And so is this side. I want to show you a couple of things. These marks right here mean that these two sides, this side and this side, have the same measure, or they're congruent to each other. And then I can look at these two marks right here, 2 hash marks on each side. 2 like swipes means that this side is congruent to this side. Congruent means that they're equal in length, have the same measure. Our last question is about a rectangle. It says that it's not our last question, I lied. The perimeter of a rectangle is 32. So P equals 32. Well, this is a rectangle. We know that opposite sides are congruent. So if this side has a measure of 3x plus 3, this side also has a measure of 3x plus 3. And if the width is 3x minus 5, then this side is also 3x minus 5. I'm going to try and do this one a different way just to show you that there are multiple ways to do this. I'm going to start by combining like terms right here. Because remember, perimeter is adding up all the sides, so I'm going to add up all the x's. 3x plus 3x plus 3x plus 3x. Well, that equals 12x. And now I'm going to combine the constants. Negative 5 plus 3 is negative 2. Negative 2 minus 5 is negative 7. Plus 3 more is negative 4. That's my perimeter, and that equals 32. I'm going to add 4 to both sides. 12x equals 36. Divide both sides by 12, which means that x equals 3. So what are the dimensions? Well, the length is 3x, well, 3 times 3 plus 3. 3 times 3 is 9, plus 3 more is 12 inches. And the width is 3 times 3 minus 5. And 9 minus 5 is 4. So my width is 4 inches. Okay. Our last one is about a line segment. We have a line segment. It's segment FG. So I'm going to draw a line segment. FG. It says that O is the midpoint. O is the midpoint. That means that O lives in the very middle. Well, if O is in the middle, that means that this half or this segment is congruent to this segment. 1/2 plus 1/2. We've divided the segment in half. Well, we're told that the measure of FO is 3x plus 17. We're also told that the measure of OG is 7x minus 15. So I've drawn a picture, but each one of these segments are congruent to each other. They have the same measure. They're equal. So there's the equation that I'm going to use. So the first thing I'm going to do is subtract 7x from both sides. 3 minus 7 is negative 4. So I have negative 4x plus 17 equals negative 15. The next thing I'm going to do is subtract 17 from both sides. That gives me negative 4x equals, same signs, add them together, 32, keep the sign. Divide both sides by negative 4, divide both sides by negative 4, and I find out that x equals 8. X equals 8. Well, what is the measure of FO? Well, 3 times 8 is 24, plus 17 is 41. What is the measure of OG? Well, 7 times 8 is 56, minus 15 is 41. What about the measure of FG? If I take 41 plus, that's segment FO, plus 41, I get the measure of the whole segment. 41 plus 41 is 82. Okay. I know that was a lot. So really your homework for today, you have an interactive practice and a homework, but you're going to do more of this whole solving multi-step equations and using applications tomorrow. Okay. So you're going to have more of the same thing.